So the first thing we're going to do in talking about circuits is basically just make sure it's very clear both the symbols and the functions that we're going to use for the circuit elements that we're going to end up talking about in this class. So let's start with the most basic. So an ideal wire. An ideal wire basically is just going to be a line. Its point is simply to provide a path for the current to flow. There's no resistance in an ideal wire. So obviously the ideal part here is the fact that we're going to care about wires that don't have resistance. If it does have resistance, we're going to call it a resistor. Switch, this is its symbol, and again you've got sort of currently this is drawn as an open switch. Obviously you would connect the two ball heads here to close it, and the purpose of a switch is to break the pathway for current to flow. So what that means is, if the switch is open, there's no current flow, because part of what we'll talk about is that for current to flow within a circuit, there has to be a complete pathway for it to go all the way around. So when you open a switch, you break that pathway, no current flows. When you close the switch, well, now you've given it a complete pathway to flow around, and so current will flow. So these are the first two elements. Then there's sort of the four main ones that we're going to deal with. First one is the battery. And you notice that the battery has a longer line and a shorter line. The longer line is the positive terminal. So this is the positive terminal over here. Shorter line is the negative terminal of the battery. And the function of the battery is going to be to provide the energy. Right? So we'll see that one of the things that we're going to care about a lot with circuits is energy. Circuits are really fundamentally conservation of energy problems. So the battery is the one that provides the energy. Second element is the capacitor. And you notice there's not a lot of difference between the symbol for the battery and the symbol for the capacitor. The capacitor simply has two lines that are of equal length, whereas the battery's got one long one and one short one. And we'll talk about why this is, because in many ways a capacitor will function like a battery for brief periods of time, because you're able to store energy in an electric field within a capacitor. So what you'll see is a capacitor gives you a way to put some amount of charge on one plate, you'll put an opposite amount of charge on the other plate. That will create an electric field between your plates, and you're storing energy. You can then get that energy back by basically letting those charges flow back off the plates. Third element is going to be a resistor, and so it gets this sort of up and down looking line. And a resistor, fundamentally what it does is it dissipates energy. Part of what resistors do is basically they're going to convert electrical energy into heat and light. So resistors that you know, there's a resistor in your toaster, right? There's a resistor in an old incandescent style light bulb. So what those resistors do is basically they resist the current flowing through them. They then convert the energy that current possesses into heat or light. And then the last element that we'll talk about is the inductor. And again, it gets this sort of this squirrely line little symbol here. And what an inductor is there's a lot of ways in which an inductor and a capacitor are very closely related. An inductor will store energy in a magnetic field. So a capacitor is going to store energy within an electric field. An inductor is going to store energy within a magnetic field. In terms of units, well, so the battery, its key quantity is going to be the potential difference, voltage. Again, all these are really the same thing when you're talking about what's going on within a circuit. So we'll use these phrases interchangeably. And the units that we're going to use for this will be the volt. Capacitor, its key quantity is going to be the capacitance. That'll be big C, and it's going to be measured in farads. And we'll see that with capacitance, our values for capacitance, much like our values for charge, we're never going to run into, or at least not in the real world, something that has 1 farad. These tend to be microfarads, nanofarads, picofarads, very small numbers. Resistors, their key quantity is resistance. And again, that's going to be big R. The SI unit for resistance is the ohm, and it gets a capital Greek omega when we're talking about the SI unit for resistance. And then the inductor, unsurprisingly, its key quantity is inductance. So you've got capacitors, capacitance, resistors, resistance, inductors, inductance. We're going to use an L for that, and its SI unit is going to be the Henry. So these are the four main elements that we're going to deal with within circuits. And so we'll start by just hooking up capacitors to a battery, then we'll start by hooking up resistors to a battery. And if we just use a set of capacitors or a set of resistors, we can deal with what's known as a steady state circuit. Things will effectively reach an equilibrium state very quickly with either of those, and then they're doing whatever they're doing. When we start mixing elements, putting together capacitors and resistors, or resistors and inductors, inductors and capacitors, then we're going to have things that are changing in time. And so instead of having a steady state circuit, we'll have a circuit that has time variation to it. And so what we're going to do is initially start with just our steady state circuits, and then we'll come back and talk about our transient circuits later.